Well, it's been several intensive days, accompanied by this prestigious scholar, who is Guy Brasseur. We were the other day, he was receiving the prize for the Juan something Molina, a scientist that grew up in this country in the 1800s or the 1700s, and he got that prize the other day in CONICYT. But and that makes it a privilege for us to have him here not only this month, but also several months coming along in the spring, Southern Hemisphere. What to say is we have been around working, talking to people, discussing some ideas, discussing collaborations in the framework of climate services, which is one of the things we said we were supposed to develop within this center and in collaboration with the Weather Office. And I'm very happy to see there are plenty of people coming from the Weather Office. So it's not only talking, there's also exchange. And, well, nothing else but to leave the floor for Professor Guy Brasseur.
Okay, thank you very much. If you saw me before, you just saw that, you know, I got a haircut, but I had to see a general this morning, so at the Incheons, you know, there's no choice. Okay, I would like to talk to you a bit about climate services, but I would like to put that a bit in a context of how the science has been evolving, let's say in the last probably 30 to 40 years. And in fact, or even before that, in fact, if you look, and when I make this presentation, I like to highlight a few important steps in the science of climate. First of all, we can go back all the way to 1824, when the French mathematician Joseph Fourier introduced this concept of a glass ball around the Earth. That was kind of the predecessor of the greenhouse around the Earth. And then in 1896, Svante Arrhenius in Sweden was very worried that maybe we would go back to some ice age, and that we needed to do some geoengineering, he didn't call it this way, in order to prevent a cooling of the planet. And he said there is an easy way. Let's just burn the coal that we have in our mines, and we will produce enough greenhouse warming. And he calculated that if we did all that, we would increase the temperature of the Earth by about 5 degrees. And he took into account feedbacks already. And in fact, this number is not very far away from what the biggest complex models are now producing if we double CO2 in the atmosphere. So that was the first step. I think it's important also to mention that starting in the late 50s, David Keeling at Mauna Loa, at a station here that is at 3,500 or 600 meters above ground in the middle of the Pacific Ocean in Mauna Loa, 3,396 meters, were measuring CO2 and showing that CO2 was increasing. So that's a kind of a milestone. Of course, there were been also some modeling effort, and probably the most prominent one is Manabe at GFDL, who tried to look at the effect of doubling CO2 concentration in a general circulation model. And basically, this was the first really climate model that was really looking at human activities. Now, in the 70s and the 80s, there were a number of environmental problems on the table. Acidic precipitation. You know, people were noting that the lakes were getting acid, especially in the northern European continent, but also the forest was dying, and that finally humans, by releasing SO2, were in fact acidifying precipitation. And a lot of the work that has been done at that time has still relevance on the climate effect, in particular on the role of aerosols. So all that has been coming together. The destruction of the ozone layer in the 70s. People were thinking that supersonic aircraft that were in the mood of being produced at that time would destroy ozone in an important way. Then came the ozone hole due to the CFCs, and then climate change and global air pollution, smog, ozone particle, etc. So if you look at the past accomplishment done since the 70s in science, it has been tremendous. The community has been extremely active. Well, in the 70s, we introduced supercomputers, vector machines, that were able to treat climate models. Satellites transform really data that we had available. The first global warming aspect were done. And I can go on like this by showing you a number of accomplishments in the 80s with land models, in the 90s when we studied IPCC, and then in the 20s where people started to think about stochastic approaches, biogeochemistry, very high resolution models, and so on. So there has been a lot of progress. Now, the problem were put on the table, and so the policy community started to get involved in this. And in 1972 in Stockholm was a first landmark conference, the predecessor of the UN conference of Rio, that took place. And at that time, see the audience here, recognized that the Earth's capacity to produce renewable resources should be maintained, and that technology should be used to improve the environment. Research and education in environmental science should be promoted, and international cooperation was very important. The same years was created the United Nations Environment Programme to provide leadership and encourage partnership in caring for the environment by inspiring, informing, and enabling nations and people to improve their quality of life without compromising that of future generations. This is what we call today sustainability. And of course, international programs for research were created. Oops, I'm going too fast here. In the beginning of the 80s, the World Climate Research Program was established to really try to look at predictability of the climate system and trying to make prediction of the response of the system to human activities. So you can see, and you might know some of the projects that part of the World Climate Research Program. Climate variability, dealing with the ocean and variability in the atmosphere. GWEX, which is the global energy and water experiment, looking at essentially the water cycle. CLIC, which is looking at the cryosphere, and SPARC, which is looking at the stratosphere and its impact on the troposphere. So it was also recognized, of course, that climate could not be isolated from many other issues. And this issue can be energy and carbon, water scarcity, food availability, air quality, human health, urbanization, population migration, for example, and poverty and education, which are all related to that. And so, in order to address these complex questions, we needed to understand interaction and feedbacks, how the biophysical and social system were interacting with the climate system, look at new approaches, new priorities, and create new partnerships. And so another international program was put together, if this wants to work, and this is the IGBP, the International Geosphere Biosphere Program. It was launched in 1987, and of course it was dealing with a number of issues: the atmosphere, the land, the interaction between land, atmosphere, and ocean, the ocean, and finally, you can see here all these projects that you know, for example, some of you know very well IGAC, which is one of those projects, but there are others, and it's all to get an integrated approach to understand the Earth system. So we move clearly from multidisciplinary science to interdisciplinary science. And this diagram is relatively famous. It came out of a study in the US with the focus on the physical climate system and the biogeochemical system, and you recognize the two major. and you recognize the two major program, IGBP and WCRP, but of course it was recognized that all these parts interact, including, of course, the human dimension that was represented by the International Human Dimension for, International Human Dimension program. Okay, and so you could see in the agencies, for example, like NASA, trying really to investigate, to try to get a health check of the planet from different perspectives: atmospheric composition, cryosphere, carbon cycle, geohazard, weather, and so on. So all that was put together, and now you see that, you know, this is an example here from one of the satellites, European satellite. You can start having really a detailed understanding on how the system is functioning, what the emissions are, what the seasonal variation are. We have all this information. This is on the data side or the observation side, but on the modeling side, there was a recognition also that the system was getting more and more complex. And so what you could see is that the individual PIs which were working, or the small teams that were working in the 70s, got gradually replaced by larger teams that were distributed in different laboratories, interdisciplinary, sometimes working between agencies, and at the end, trying to get a full Earth system view of in the models. And today you have those Earth system models that look at, atmosphere, ocean, paleo, bio. You can see the whole aspect. Software engineering is becoming very important. So with all this knowledge, it was important to recognize that the knowledge had to be disseminated. And so the first attempt was, of course, by the community starting in the early 90s to try to develop these IPCC activities. And IPCC has been a major activity that has had a major influence on the policy world, but of course, as you will see, it has some limitation. Now, today, this is from the last IPCC, people start to move really into things like regional, key risk, and potential for risk reduction. So the idea of going from the physics, the uncertainty associated with the physics, into some risk estimate is becoming very important. So IPCC had a major influence on a number of policy activities, in particular the development of international agreements. So this is here that shows you, since the conference in Stockholm that really started all that, the number of agreements that have been signed, multinational, multilateral agreement, basically the number of agreements that have been signed to protect the environment is about 500. The number of parties involved has been extremely large, as you can see. And then you can ask yourself, has this been very useful? Have we really protected the environment? So the best way to do is to look at each of them and to do what we call a scorecard. A scorecard for the environment. This is in 2012. And you see here a number of agreements that have been signed. If you are in the green, it means that there has been a real improvement in the environment. If you are going to the red, it means it's even worse than it used to be before we agreement. And so you can see that there are two agreements where the judgment has been that they have been very useful. One is the stratospheric ozone issue, and the other one is lead in gasoline. If you look at outdoors pollution, some improvement, but it's still not very good. Climate change, there's no real improvement in spite of all the agreements that have been signed. And you can go on biodiversity, on chemicals and waste, on land, on water. Here's one. Drinking water has been improving in the world also. But for the other ones, there's not been a real success. And clearly, the IPCC system with the negotiation at the end have not solved all the problem. We have to go beyond that. And so the concept of climate services comes up naturally as a way perhaps to create this link that is missing between the scientific community and society. And so I put it first, the dream. What are we trying to do? I'll talk about reality in a minute. So a number of people have been saying, well, to go between research and operational activities, you have a real valley of death. This is where things are not working. There's availability of resources for research, for product definition. There is resources for using products, but the communication, the institutional support, the resource commitment to link basically the research to the operational is a real death valley. And you can see it on this graph here, basically that shows, this is here what the scientists are doing, this is here what the users are doing and the resources that exist. And in reality, data generation may be adequate, integration, analysis, interpretation already problematic, delivery weak, and finally appropriate informed adoption of this is mixed. One of the issues is that scientists are forced to face communication into a value conflicting context. And they are not accustomed to that because there are a lot of choices that need to be done along this road. And it's a very different way of working. Oops. So climate services, what do? They provide reliable, well-documented, authoritative, and easily used information. And they develop the most effective approaches to mitigation and adaptation strategy. That's what a climate service is supposed to do. But to do that, they need to develop sustained, nationally and regionally based interaction with users in different economic sectors. So that's what the purpose of climate service is. It's to bridge basically beyond what things like IPCC have been doing. Okay, it's a very complicated structure. You have the science here at the bottom with a lot of the issue that you all know about, CO2, deforestation, glacier, and so on. But now you move into something that's much more complicated, the economy, the society, law and governance, finally to come to the top where adaptation and mitigation are there. So, and you have a context. You have the international agreement. You have a number of other aspects outside. So it's a very complicated task to do. So I'm going to pass this. So there are, of course, a number of orderly activities that have been put together. At the World Climate Congress or Conference from WMO, there was established a global framework for climate services, again with adaptation and mitigation. And so you see the different research program. I mentioned the World Climate Research Program. We have also the Global Climate Observing System. We have IPCC that is here. We have the Framework Convention for Climate Change. But now the new piece that has been used is this one with a Climate Service Information System, a user interface problem, and a sectoral users. And this is really at the moment under definition, and we will see, of course, if it's working. Now, I think that as we talk about climate services, we can distinguish between two different approaches. What I call the top-down approach, which is the development of a large database and dissemination of data available. It's basically an extension of meteorological services, just provide more data on climate. But there is also the bottom-up approach, which is a more complicated approach, where you initialize a dialogue with stakeholders, you identify their specific needs, you look toward solution to their problem, and it's really very often an extension of research groups, university in particular, involved in adaptation science. So let's look quickly at the top-down approach in a few minutes. And you see it here. Essentially what we do is to anticipate climate change while considering uncertainty. We go all the way from models all the way to impacts and physical vulnerability. And the professional community that are involved are the traditional climate science, modeling, data analysis, and so on. And so, here's an example where, we work on those models, we work on the data, we do some downscaling, we go down to impact research, practitioner, adaptation, policymaker. So it's going from the bottom from the top to the bottom, with, of course, a lot of public resources here, but then more and more public and private activity that need to be involved. So example of data, I was showing that in fact for René because he asked me about it. This is what NOAA is doing. And NOAA has this global climate dashboard where you can find a lot of information about past climate and then also about future climate. This is an example here for a period that goes, I think it's basically from 1950 to 2020. You can also look at climate variability. This is now here over 1980 and 2002. You see the El Nino index, you see the Arctic oscillation, the North Atlantic oscillation. All these data are available and you can stretch them to get more and more time resolution if you want. This is the kind of things that meteorological centers are providing. This is the US example. Now in Europe, now they're building essentially the Copernicus Climate Change Service, C3S, which will have a climate data store that includes essential climate variables, observation, reanalysis, climate indicators. They will have sectorial information systems, so tailor indicator to users. They will have an evaluation and quality control activity, and also an outreach and dissemination activity, liaison with users, training, etc. Let's say a word about the other approach, the bottom-up approach, very briefly. And here, of course, we look at this approach here, where we start talking about information, equity, technology, infrastructure, indicative, adaptive capacity, and looking at the social vulnerability. And so here we want to analyze how socio-ecological system will be affected by climate change, and the communities involved are different communities: impact, vulnerability, adaptation, social science, economy, international negotiation, carbon trading, political science, etc. And so here, of course, we deal with vulnerability, exposure, very different. And you can see here, of course, that the approach is very different. First of all, you have to scope your problem, identify risk, identify vulnerability, establish this decision-making criteria, and then looking at implementation, and looking then at the analysis, how you can evaluate your effort and how successful you have been doing. So the social science group and some international program are dealing with that. I'll come back to that in a minute. Now a word about dissemination, because I think this is very important. And I'm going to pass this and say that, in the past we had the so-called deficit model, that's now it's called, where basically expert generates almost infallible knowledge. This knowledge is then communicated as being the correct information, and then the public reacts, believes it, adopts it, and believes that that's what it is, and act accordingly. So this was like going down, and of course you can see this system is not working. Oops, sometimes it goes fast. Okay, so essentially what the communication people will be telling you is that you have to go around things. What counts is, first of all, you have to identify the socioeconomic background, the education level of people, the personal experience of people. And then you have to look what the views of people are, the political ideology, the religiosity, the trust in science. Some people don't believe in science at all. And then you have to look at how you can put your message together. Is it through interpersonal communication or through media and so on? You have to account that only a small factor of the opinion formation is science. People form their opinion in many different ways. And so you have to really turn around. And of course, today, you also have new communication ways. The old media system where you write papers and you distribute them is today not working. It goes from a push system, as they call it, to a pull system, when in fact a lot of the information is coming from the users themselves through the social media and so on. So it's very different. But I think More importantly is that if you want to communicate and bring information from the science, for example, all the way to a change in behavior, it's not just, as I said, going down, people will believe this and will make it happen. You have the beliefs, the social system, the family system, the personal structure. You have the social norms that exist in a country, political system, economic system, and all that comes together to finally determine the behavior. So for climate services, it's very important to understand this because you cannot just authoritatively bring information in the system and believe that it will help the whole system to change. So in fact, you have to take a broad view, and this broad view implies the physical Earth system, as I mentioned, and also the socio-ecological system with climate economics, climate politics, climate communication, and so on. So let's look a bit at the reality and the lesson learned over the last years. It's tired, huh? Okay, ready to. Yeah. So the first thing that we have learned in operating for 5 years in Germany is that the dialogue with stakeholders is difficult. First of all, every case study, every user, every potential user is different. So there is nothing like, I'm going to put a product on the table and this will be used by everybody, which the economists are telling us to do. They just say, if you want to be successful, come up with one product and make sure everybody uses it. It's not working. The decision-making context is key. It's not only your information that's important. So a sectoral focus is important, and you can assume that users know they need a priori. So don't go to them and say, hello, what do you need? They don't know. Sending out questionnaire is not optimal. It's much better to have a focus group, interview, but it's also more time consuming. And then this step, as I said, takes a lot of time. So this dialogue with stakeholders is something that takes immense amount of time, and you need to be ready to do that. I just wanted to show you also to highlight this complexity. These are recent Codex results that kind of predict the humidity in the soil, the water in the soil, based on different models. And just take those two here. Now, this guy says it's going to be drier. This model shows it's going to be wetter. So then you can look at all the other ones. Some are red, some are blue. How do you communicate this kind of information? What do you tell people? You can see that, it's not a linear process. You have to explain why you get these kind of things. You have to introduce that there is a probability distribution and that the answer is not so clear. So I'm just showing that because I like to show you how difficult things can be. So the reality. Experience has shown that there is, first of all, no fully developed market yet for climate adaptation product. Don't believe that the customers will come at your door and say, we need information because we want to adapt to climate change. Now, the only market that exists a bit is for climate mitigation products, but there are a lot of small little companies that are doing that. And so if you are working as a climate service that is a national climate service, you will immediately find a lot of small corporations that helps the companies to reduce their carbon footprints and do that. They're not scientists, they're really at the engineering level, but you cannot really compete with them because, so we have always felt that we needed to go into the adaptation domain, but the adaptation domain doesn't have necessarily a great market, and so you're not going to make money out of the climate service that you can be producing. Now, one of the reasons that climate adaptation doesn't have so many customers is because there is no strong legislation. You're not forced to adapt to climate change at the moment. This could come in the future. Another reason that makes your connection with stakeholders difficult is that the business model of the climate service does not fit the business model of many corporations. Corporations want to have a quick answer on their questions and are not necessarily ready to give you money for 6 months or for a year to do a study. They come on Friday, they want a response on Tuesday next week, and you have to do that, and you cannot do that necessarily easily in an environmental setting like a university or a research center. So a lot of corporations will try to find climate services as being small private companies, startup company that don't care very much about the excellence or the accuracy of the data, but responds very much in line with what they want. A third reason for difficulty are the timescales involved. And their timescale associated with climate change are considerably longer than the strategic planning horizon of most institutions. And so, you're going to talk to them about 30 years, 40 years, 50 years. Some are interested. Infrastructure, banking, might be interested over those long term, but most of the company are looking for 5 years or so ahead of them. And so somebody was showing me this, Milton Friedman, the Nobel Prize, said the social responsibility of business is to increase its profit, period. The business of business is business. It's not the environment. And so corporations do not understand how climate information will improve their business. And if you want to be successful with the corporate world, you have to show that you're going to improve their business. Their income will increase. Now, there are some exceptions and trends. For example, the New York Times had a style, Climate Cost Awaken Industry. Coca-Cola recognized that climate change is an economically disruptive force. Now they start to be interested a bit. It reflects a view among American business leaders and mainstream economists who see global warming as a force of lower gross domestic product. So if you see that climate is damaging the efficiency of corporation or the GDP, they might start to open their eye and be interested. So Bloomberg, the former mayor of New York, as well as Paulson, the former Treasury Secretary in the Bush administration, have been commissioning an economic study called Risky Business on the financial risk associated with climate change. So you can see the first aspect. There are other quotes, for example, in the agriculture, that it becomes a bit dangerous. Okay. Now, the business environment has started to define what they see as climate service. And they call it the 3 E's: engagement, entrepreneurship, evaluation. And so it's interesting to read all that because, they're talking about building trust between provider and customers and clients, support learning of clients, need to be sensitive to climate change. They're looking entrepreneurial process can help climate providers better innovate. So you can see that it's a very different philosophical approach than the one we hear. They want to evaluate, look at performance matrix, and really make sure that it's not disruptive of their business. So, top-down climate service provide data, but this is not what users generally expect. That's my experience. We have all this data, and they say we cannot do anything. I was talking recently with a person in charge of the protection of Holland from the delta from sea level rise. They say, we see all your prediction that sea level will rise. We know that. We know that. So we have to do something about it. But in order for us to do something about it, we have to invest in terms of putting new dams. And so we need to know when this will happen. Is it something that will happen in 20 years? In 30 years, in 50 years, in 100 years. It's a completely different business model for us, an investment scheme for the government to do. And these are the kind of information that we want to know. Private corporations are interested by climate service that can respond in a very short time frame to their specific question. Public service works around contracts, and have relatively inflexible rules that are not competitive with private consulting firms. That's a problem that, at least in Europe, I've seen important. So perhaps we should be thinking of a new approach for climate services. That should be some kind of independently managed institution, very flexible, based on an operational partnership between, I said three, in fact, four different groups: meteorological services, the weather service, that provide the physical data, model simulation, and an example is the 3CS that ECMWF is putting together, and also scientific organizations that are data providers. Number two, we need to bring in impact, adaptation, vulnerability specialists. They're coming from the academic world, they are coming from the economy, consulting firm. Number three, representative of the corporate world with good knowledge of the culture in the private world and also representative of the public service. And then social managers, strategic communication specialists, all under the same roof. That's important so that inside the system, a dialogue between these groups is developing, and finally the language that's coming out of the climate service is not the language that's coming out only of the research institution and organization. The other thing that I also wanted to make, this is made for, in fact, Belgium, because I did a study for Belgium. And when you talk about climate service, there is a whole chain that you need to take into account. In our case, we have the European initiative, we have the national Met services, we have the sectorial research organization dealing with energy, agriculture, water. They add the sectorial information. Then we have the synthesis and translation for users at the national level. We need the communication, and so here boundary organizations like NGO, unions, professional organizations are important. And you see here national users, policymakers, professional organizations. Then you have to go to regional climate service, and those adapt information to the need of individual users and advise regional government. And finally, you have the end users, which is the vulnerable community, individual actors, farmer, industry that may use of this information. So how to bring all this together is, of course, a major challenge, but it requires the building of a chain of cooperating institutions. Okay, I think I'm going to wait here. A few more things about the international organization that do research, because I think it's important, in spite of the development of climate services, that we keep a vibrant research program, relatively fundamental program. So, for example, the World Climate Research Program that facilitates analysis and prediction of Earth system variability and change for use in an increasing range of practical application of direct relevant benefit and value to society. And you see here the organization of the World Climate Research Program, dealing with ice, ocean, land, atmosphere, looking at big cycles, doing modeling, observation, and finally moving all the way to the climate information on different time scales, including the shorter decadal time scale, and finally touching into the climate service. These are now the grand challenges that WCRP is putting together. Regional climate information, sea level rise, cryosphere and the changing climate, changes in water availability, cloud circulation and climate sensitivity, and climate extreme. These are the big topics now in climate research, and now seasonal to decadal analysis and prediction is, of course, very important in that regard. But beside WCRP and the World Climate Research Program, you have now an emerging project called Future Earth that want to provide knowledge required for society in the world to face risk posed by the global environmental changes and to seize opportunity in a transition to global sustainability. And they worked around three pillars, what they call the dynamic planet, which is to a large extent what WCRP can bring. So it's the physics, the biology. They deal with global development and transformation towards society. So it's much more looking into the social aspect of climate change, dynamic planet, observing, explaining, understanding. Then you have Hello. The global development, providing knowledge for sustainable, secure, and fair stewardship of food, water, biodiversity, health, energy, etc. And finally, the transformation towards sustainability. It's to understand the transformation processes, an option assessing how these relate to human values, emerging technologies, economic development, and so on. And I'm going to finish by quoting Walt O. Roberts, who was the person who created NCAR. You see here a picture of NCAR where I spent 20 years of my life for my research. And he said, science exists to serve human welfare. It's wonderful to have the opportunity given us by society to do basic research. But in return, we have a very important moral responsibility to apply that research to benefiting society and humanity. So this was a bit of an overview of the thinking we have around climate services, the goals, the dream that we have to create a bridge with society, but also the difficulty that we are facing and the necessity perhaps to rethink a bit the way climate services are being established. Thank you.